Okay, hello again. Welcome to another lesson in Algebra 1. Today we are covering section 8.1, power and product rule for exponents. So you had a warm up. That should be some quick review on exponents. So remember, 2 to the 5th power does not mean 2 times 5. It means 2 times itself 5 times. And you do not have to expand this, but I'm just showing you where it comes from. So 2 to the 5th power actually works out to 32. All right, so negative 2 to the 4th power. Remember, the negative subtraction comes after exponents in the order of operations. So this negative is really like a subtraction. So we're going to do the exponent part with the 2 as the base, and then we're going to make the whole thing be negative afterwards. So this will actually become negative 16. Be very careful on that one. It's a common mistake. But if you use a calculator and type it in, the calculator does know the order of operations and will get it right for you. All right, 3 squared is 3 times 3, which is 9. And then our last one, order of operations, parentheses come before exponents, so we would have to use the negative 2 4 times here. So negative 2 is the actual base. In number 2, positive 2 was the base, and then the whole thing was negative. And in number 4, negative 2 is the base. Okay, so when I multiply these together, they make 16. It's the most common missed parts of exponents. Okay. All right. Expand first to help simplify, and then write your answer in exponential form. So 2 squared is 2 times 2, and then we have 2 squared again, so 2 times 2. And we're supposed to write our final answer in exponential form, so this will become 2 to the 4th power because I have 4 2's. So expanding means write out all the things without exponents and then put them back together. Okay. So x squared times x squared is x times x, and then we have this multiply in between. And then x squared is x times x again. So now we have 4 x's, so this is x to the 4th power. And number 3, let's expand this out. So number 3 is 3 times 3 times 3. Then we have multiply in between. And then we have 3 times 3 times 3 times 3. So there are 8 3's now. So we rewrite in exponential form is 3 to the 8th power. All right? And number 4, x to the 5th is x times x times x times x. Then we have this multiply in between. X squared is x times x. So this is expanded form, and then we're going to put it back together. So there are 7 x's here, all multiplied together. So that's x to the 7th power. So remember, exponents, just repeated multiplication. So we can expand it out to a multiplication problem and put it back together for an exponent problem. So x to the 4th is x times x times x times by x times x times x times x. There's 8 of them. So this is x to the 8th power. By now you might be noticing a shortcut. If you don't, then we'll talk about it in just a second. X to the 3rd power is xxx. Then we're going to times that by x to the 7th power. So there are 7 of those. 1, 2, 3, 4, 5, 6, 7. And then we multiply it all back together, so there's 10 x's being times together, so we can rewrite that in exponential form as x to the 10th power. All right. If you didn't notice, there is a shortcut to these. If you multiply two things that have the same base, two exponents with the same base, then all you have to do is add the exponents. So in this case, we are adding 2 plus 2 for 4. Keep the same base and just add the exponents. So we kept the same base as x, and we added 2 plus 2 for 4. We kept the same base as 3, and then we added 3 plus 5 for 8. We kept the same base as x, and then we added 5 plus 2 for 7. So they have to have the same base for that to work. So in all these, all of them have the same base. So x is the same base, and 4 plus 4 makes 8. X is the same base in both, so 3 plus 7 makes 10. All right. So when we flip it over, we'll see a rule for that. Okay, so the rule on the second page is called the product rule. Okay, so the rule for multiplying terms with the same base, so we have x and x, those are both the bases, is just to add the exponents. So the m and n exponents get added together to make m plus n. So let's use that rule to simplify a couple problems here, save us some time. So 2 times 3. Okay, so these are two terms being multiplied together. The 2 and the 3 are the coefficients of the term. They just multiply to 6. There's no exponents on them. The exponents are both 1, so you just times them together, 2 times 3. Okay, there's a's with exponents in both of these, so we just combine the exponents with 2 plus 3 to make 5. All right, number 8. The coefficients are both 1, so 1 times 1 is still 1. We don't need a 1 in front of this. So we have x and y base both. In the first term, we have a 1 exponent on the x and a 2 exponent on the x in the second term, so 1 plus 2 makes 3. And in our second part, the y terms, the y parts have a 2 exponent and a 1 exponent for 3. Okay, so the y base gets exponent of 3, and the x base gets exponent of 3. And number 9, we multiply our coefficients together to get 6. 2 times 3 is 6. And then in this case, we have x's and y's for the base. The exponents on the x base in the first term is 3, and in the second term it is 1. So 3 plus 1 will make 4. And the y's exponent in the first term is 1, and in the second term is 5. So 1 plus 5 will make 6 there. So 6x to the 4th, y to the 6th. And number 10, we have a 1 coefficient in our first term and a 2 in the second. So 1 times 2 is 2. Those aren't exponents, so we just multiply them normal. And then we have w base and v base. The w is going to get an exponent of 4. That's 2 plus 2 for the 2 exponents on the w base. And the v is going to get an exponent of 6. That's 5 plus 1 for 6. Number 11. Our coefficients are negative 1 and 2, so they're going to multiply together to make negative 2. And then we have some x's and some y's. So the x exponents on the x basis are 4 and 4, so 4 plus 4 will make 8. And on the y's, 2 plus 3 will make 5. All right, number 12, our last one here. We have A, we have B, and we have C. The coefficients are both 1, so we just leave a 1 coefficient. The bases are A, B, and C, and the exponents on the A are 5 and 5, so add them together for 10. The exponents on the B are 4 and 1, so add them together for 5. And the exponents on the C's are 3 and 2, so add those together for 5. All right. So that finishes up the product rule. Okay, so we have some different ones here for the second section. It says expand first to help simplify. So we're going to do it the long way first and then look back for shortcuts. All right, number 13. 2 squared to the 3rd power. Okay, so that's 2 squared times itself 3 times. That's what to the 3rd power means outside of those parentheses. So I take the base of 2 squared and I times it 3 times together. Okay, so I'll expand that even further. So that's 2 times 2, 2 times 2, and 2 times 2. So that's 6 2. So this is 2 to the 6th power. All right, we'll do the same thing with x's here. So x squared to the 3rd power is really x squared times x squared times x squared. So that's xx times xx times xx, which is x to the 6th power. Number 15, x cubed squared. That means I take the base of x cubed and times it to itself twice. So x cubed times x cubed. So this will be xxx times xxx. That's 6 x's all together, so x to the 6th when I put it back together from expanded form to exponential form. All right, so by now you're probably starting to notice a shortcut, hopefully. Maybe something you could do with the 2 exponents to get the new exponent, but if not, we'll talk about it in a little bit. Number 16, we have this base multiplied 3 times. Okay, so this is xxyy, xxyy, and xxyy. That's 6 x's, so x to the 6th, and 6 y's. So in expanded form, there are 6 x's being multiplied together, so exponential form is x to the 6th. And there are 6 y's being multiplied together, so exponential form is y to the 6th. All right, 17, we have a squared b cubed times itself 2 times, because the exponent is 2 here. So a squared b cubed. Put them together, that's a to the 4th, b to the 6th. So we could shortcut it and use our power rule here if we felt like it. Our product rule from above, I'm sorry. So that's 2 plus 2 for 4 and 3 plus 3 for 6. Okay. All right, number 18, let's use the First we'll expand it to here, 2x cubed times 2x cubed. And then we'll make use of our product rule from above. So multiply the coefficients together and add the exponents. Okay. Now we don't have to use the product rule from above. We can learn a new rule. So let's take a look at what we're doing with the exponents in this case. If you look at number 1, how could I take the 2 and 3 exponents and turn them into a 6? Same with number 14 here. 2 and 3 turn into a 6. And then here, 3 and 2 turn into a 6. And then here, 3 goes with this 2 and this 2 to make 2 6s. Okay. Here, 2 goes with this one and this one to make a 4 and a 6. And in the last one, the 2 and the 3 go together to make 6. Okay, so what we're really doing here is just timesing the exponents. So I take each one, I could just multiply them together to get the new exponent. So in number 14, 2 times 3 makes 6. And number 18, 3 times 2 makes 6. Okay, so timesing the exponents will work for us. And that rule is called the power rule. Okay, if we have one base that has an exponent and then there's parentheses around it, we have another exponent outside to that whole base, and we can just take the outside exponent and multiply it to all of the inside exponents. So use the power rule and the product rule to help simplify each. So remember that every exponent, or every base has an exponent, whether it's one there or not. So like this 2 really has an exponent of 1 there. So I'll take the 5, and I'm going to multiply 5 times 1 to make 2 to the 5th power, and 5 times 2 to make m to the 10th power. And then we go ahead and work out 2 to the 5th power. 2 to the 5th power is 32. It was on our warm-up earlier. Okay. All right, so in our second one, we really have -3, and then that had an exponent of 1, so 1 times 2 is 2. And a and 2 times 3 will make 6. Okay. So -3 to the 2nd power is 9, and then we bring down a to the 6. So it makes these a lot shorter. We don't have to write it out so much. So in this one, the same thing. -5 is my base. It had an exponent of 1, so 3 times 1 will give it a new exponent of 3. And then x had an exponent of 1, so 3 times 1 will give it a new exponent of 3. So -5 to the 3rd power is -125, and then we get x cubed. All right. So it did say power and product rule. So remember, exponents out here are going to come before that multiply in between. So we're going to use both of our rules here. So we're going to have x squared, and then we're going to do that exponent outside of the parentheses first. 3 times 4 will give us x to the 12th. And then we'll use our product rule to put them together by just adding the exponents to get x to the 14th. Okay. All right, our last two. Same thing, we got to do the exponents outside first. So x to the 15th, 3 times 5, times x to the 6th, 3 times 2, makes x to the 21st power. Okay. And in our last one, then we have 1 and 1 in here. So 2 to the 2nd power, we'll just go ahead and write 4 this time. 2 times 1 gives me a squared, and 2 times 2 gives me b to the 4th. And then we do the second part. This has an exponent of 1 and 1. So 3 to the 2nd power is 9. 2 times 3 will make a to the 6th power, and 2 times 1 will make b squared. We put those together. 4 times 9 is 36. And then we have an a and b, so we add our exponents on the a, that'll make 8. And we add the exponents on the b to get 6. So we have 36a to the 8th power, b to the 6th power. All right, this completes our notes. So down below you have a follow-up. Okay, it's a lot of rules that we did today, but hopefully you saw them in Math 8 last year, so they're just a quick review for you. But if not, go back and watch the video again, just to double check yourself to make sure you really know what's going on. And then try these guys without looking at the answers first, and then check your answers to see if you got it right. That'll tell you if you really know what's happening. All right, I'll see you in class next time.